Okay, let's actually apply the scientific notation rules to change standard form into scientific form and to change scientific form into standard form, okay? So what I want to point out really quick is that if you pay attention to your exponents, you're going to learn a lot. So when they are positive, that means that you're actually multiplying by a 1 with 5 zeros or however many this number is, okay? So really you're multiplying by quite a large number, but really that just means we're going to move our decimal to the right this many times, okay? So when we have a negative, so by the way, when you have something like this where we're taking that decimal and we're moving it to the right, 1, 2, 3, 4, 5, right? We are going to get a big number and it's going to look like something like this. Okay, now when we're looking at a negative exponent, that means we're going to be moving our decimal this many digits, 4 in this case, to the left. So that means we're going to get a very small number. So we're going to get a decimal, small decimal, and it means we're going to move this decimal 1, 2, 3, 4 places to the left, leaving us with a number that looks similar to this. Okay. So we have kind of an idea of what we should end up with. Let's go ahead and do that now. First one, 35,400,000, okay? How do we change this into scientific notation? This is standard. Let's change it to scientific. So we're going to put the decimal after the first digit we see, the 3. So it's going to go between the 3 and the 5. So I'm going to write 3.54, and I'm going to continue to write all the digits until I just start hitting zeros on the regular and there's no more left, okay? So that's why I stopped there and I didn't include all my zeros in there. Now the next thing I'm going to do is I'm going to put in my times 10 because that's what scientific notation dictates, okay? Now we need to find what our exponent is going to be. Now this is a large number, so this exponent is going to be positive, okay? Now let's see how many times we had to move that decimal to get to this place, okay? So this is where we put it. So let's start moving that decimal and counting to the very end. 1, 2, 3, 4, 5, 6, 7. 7 places to the right we move that decimal. So our exponent is 7, okay? All right, let's try the next one. Now don't fret that this is a negative, that's okay. The first digit is 4, so our decimal is gonna go between the 4 and the 0. So 4.02, and notice that's where I stopped this time because, well, honestly, that's where our number stops, right? Then I'm gonna put in my times 10, times 10. Now, remember, this is a negative, so don't forget that negative, okay? You might want to put it in the beginning. Now, how many times, this is larger, I know it's a negative, but we look at the absolute value of it. How many times do we have to move that decimal to get to the end from the new placement between the 4 and the 0? Well, we had to move the decimal 1, 2 places to the right. So our exponent is a positive 2, okay? All right, so that is changing standard form into scientific. Now, let's try a smaller number. Now notice, these were big. This is, the decimal is to the left of the digits. So we are going to go ahead and look at our first 2 digits. I see 8, 2. So my decimal is going to be placed between there. So I'm going to make it 8.26. So I start 8.26 times 10. But this time our decimal moves what direction? Left, right? How many times, or I should say correct, how many times left did we have to move? 1, 2, 3, 4 places to the left. So that means my exponent is going to be a -4 because that means we moved our decimal 4 places to the left to get to